Let us discuss the point slope form of a line. We will begin by considering a point A. A has the coordinates x1, y1. Also, we will consider another point lying on the line. Let's say this is the locus of the point. The locus of the point P having the coordinates x, y. Now, in simple terms, you can think about it as the locus of a point can be defined as a point which can freely move along the line. So our point P is the locus. It can move freely along the line. However, A will be considered as fixed point here. Now, we can define the slope of this line by using the slope formula. The slope of the line can be simply defined as, we'll have to take a ratio. In the numerator, we need is the difference of the y coordinate. So here, we'll start with point P, the y coordinate of point P, and from it, we subtract the y coordinate of point A, which is y1. And in the denominator, we need the difference of the x coordinate. Since we started out with y, which corresponds to the y coordinate of point P, we'll have to start with the point P only. So we'll take the x coordinate of point P, and from it subtract the x coordinate of A. So that's going to be x1. So this is how we can define the slope of that particular line. No matter where P lies, this is going to be the formula. But we also know that the slope of a line is defined by the letter m in lowercase. So that means we have m equals to y minus y1 divided by x minus x1. Now, if we rewrite this equation, we are going to get y minus y1 equals to m times x minus x1. And this is defined as the point slope form of a line. The point slope in the sense, that means if we are given the information regarding the point, this which is the constant or the fixed point A, and if we are also provided with the slope of that particular line, then using this equation, we can find out the equation of a given line. So let's try to understand this with the help of few numerical problems. Problem number 1. Determine the equation of a line inclined at an angle of 135 degrees with the positive direction of x-axis and passing through the point 2, -3. So here we can easily obtain the slope of this line because it's given here that the line makes an angle of 135 degrees with the positive direction of x-axis. So that's the definition of a slope. So we can define the slope m as the tangent of the angle that the line makes with the positive direction of x-axis. So that's 135 degrees. So if we calculate tangent of 135 degrees, that's going to give us the slope of that particular line. Now, how do we obtain the value of tangent 135 degrees? Now, the simplest way to do would be, so we can do 180 degrees minus 45 degrees. Now, we can rewrite the angle 180 degrees as a multiple of 90 degrees, 2 times 90 degrees, minus 45 degrees. Now 2 times 90, now there's a reason why we're writing in this fashion, because here what we have is an even multiple of 90 degrees. So whenever we have an even multiple of 90 degrees, then our tangent function is going to stay as the tangent function, but the new angle will be 45 degrees instead of 135 degrees. So we have tangent of 45 degrees. But we'll also have to be careful about the sign of the tangent function, because 2 times 90 here, the number 2 is indicating that we are in the second quadrant. In the second quadrant, the tangent function is negative. Since it is negative, so that means our slope is going to be equals to -1. So now we have the slope of that particular line, and it's given here. The line passes through the point 2, -3. Now since it passes through this particular point A, 2, -3, and has a slope of -1, now what we can do? We can use the slope point form or the point slope form, which is given by y minus y1 equals to the slope times x minus x1 to obtain the equation of that particular line. Fine. So here x1 and y1 actually corresponds to point A. So we have x1, y1. This means that the value of x1 is 2 and the value of y1 is -3. So let's substitute the value. So we have y minus -3 equals to the slope m, which is going to be -1 times x minus x1. So x1 is going to be 2. So here we have y plus 3 equals to the -1 multiplied to x minus 2. That's going to be 2 minus x. Now let's rearrange everything. So we're going to get x plus y plus 3 minus 2. That's going to be +1 equals to 0. So this is going to be the required equation of the line, which is inclined at an angle of 135 degrees with the positive direction of x-axis, and it passes through the point 2, -3. Okay, let's do another problem. Determine the equation of the line parallel to the x-axis and passing through the point -4, -3. Let us begin. So here we will first try to understand the problem graphically. So here we have the coordinate axis and we have the point A. So A corresponds to the point having coordinates -4, -3. Since both x and y coordinates are negative, so we are in the third quadrant. Now we're going to draw a line. We're going to sketch a line, and this particular line is going to pass through the point A, and also it meets the condition that it's going to be parallel to the x-axis. So our goal will be to determine the equation of that particular line. Now let's do one usual way, because any line which is parallel to the x-axis, its equation is always given by y equals to b, where b is nothing but the y-intercept of that particular line. Now in our problem, it is definitely going to have a y-intercept because the line passes through the y-axis but in the negative direction. So at this particular distance, so let's say if the line intersects the y-axis at point B, then OB is going to be the y-intercept, and clearly the length of OB is going to be nothing but the distance of that line from the x-axis. So that's going to be -3. So if we replace the value of b with -3, then y equals to -3 is going to be the equation of that particular line. However, since we are working with point slope form, so we are going to use the point slope form to obtain the equation of the line and also verify that it is indeed given by y equals to -3. Okay, now to define the equation of the line using the point slope form, what we need is the slope of that line. So here the slope of the line m will be equals to 0, because any line that's parallel to the x-axis is going to have a 0 slope. Okay, and this particular line passes through the point A, -4, -3, and this is nothing but it corresponds to x1, y1, which means that the value of x1 is -4 and the value of y1, that's going to be -3. So let's substitute this value into our point slope form, which is y minus y1 equals to m times x minus x1. So we know this. So this is the formula for the point slope form of the line. So we're going to replace the value of y1 with -3. So y minus -3 equals to the slope m multiplied to x minus -3. Right. So we have y plus 3 equals to 0, which means that we're getting the equation as y equals to -3. So this is indeed correct. So y equals to -3 means the equation of the line which is parallel to the x-axis and passes through the point -4, -3. Okay, now let's go to the next problem. Determine the equation of a line that is perpendicular bisector to the line segment formed by joining the 2 points A and B. Let's try to understand the problem graphically first. So what we'll do, we'll consider our coordinate axis and plot the 2 points A and B first. So here we have the coordinate axis with the 2 points A and B. Now, in both the 2 points A and B, the x coordinates are positive, whereas the y coordinates are negative, which means that they are going to lie in the fourth quadrant. So let's join the 2 points with the help of a straight line. Now, what we have here is the line that passes through point A and B. This is the line segment. Our goal will be to determine the equation of the perpendicular bisector of this line. So let's say perpendicular bisector means a line which is perpendicular to AB as well as it bisects AB. So if it is bisecting, that means it's dividing the line segment AB into 2 equal parts, let's say at point C. So here we have AC equals to CB, or you can say C is the midpoint of AB. Now we have to find out the equation of a line which is perpendicular to AB. So this is the line, so this is perpendicular to AB. Let's call it, the line segment is DC. So we have to find out the equation of line DC with the condition that it is perpendicular to the line segment AB. And since we are going to use the point slope form, so we need two information. We need the slope of the line CD, and also we need one point which is going to lie on the line CD. Now clearly that will be the line C, that will be the point C. Since point C lies on the CD, so we will be using that particular point. So on the first task, what we'll do, we'll try to determine the coordinates of point C. Now since C, the point C is the midpoint. Since it's the midpoint of the line segment AB, so we can easily find out the coordinates of point C because we have the coordinates of point A and point B. So here we'll be using the midpoint formula to find out the x coordinate. We sum up the x coordinates of the endpoint or the point x coordinates of A and B. So the 2 will be added to 6, and then we are going to divide the result by 2. And to find out the y coordinate, we're going to sum up the y coordinates of the endpoints. So we have -3 and -5 added to each other, and we're going to divide the result by 2. So that's going to give us, so we have 2 plus 6, that's 8. 8 divided by 2, that's going to be 4. -3, -5, that's 8. -8 divided by 2 is going to be -4. So that means coordinate of point C is going to be -4, comma, -4. Fine. Now that we have the point C, our next task will be to obtain the slope of line CD. Here, we can use the condition that the product of the slope of two perpendicular lines always equals -1. We know this condition. The product of M1 and M2 will be equals to -1, where M1 represents the slope of one line and M2 is the slope of another line, and both of the two lines are perpendicular to each other. We're going to use this particular idea to obtain the slope of CD. So let's begin by first finding out the slope of slope of the line AB. We're going to denote it by the letter M1. So all we have to do is take the ratio. In the numerator, what we have is a difference of the y coordinate. So here we'll take -5 minus -3 divided by the difference of the x coordinate, which is 6 minus 2. So this will be equals to, so we have -5 plus 3, which is going to be -2, and 6 minus 2 is going to be 4. So that means our slope is going to be -1/2. And the slope of CD, let it be given by M2, say. Then we can use the idea that the product of M1 and M2 is -1. So here we have M1 given by -1/2 multiplied to M2, that will be equals to -1, which means that the value of M2 is going to be +2. Right, so now we have the slope of line CD. We also have a point that lies on the line CD. Now we'll be using the point slope form. So using the point slope form, we're going to find out the equation of a line. The point slope form, which is simply given by y minus y1 equals to the slope times x minus x1. So here we have x1 comma y1 corresponding to the point -4 comma -4. This is the point C. So we have y minus y1. y1 is going to be -4 equals to the slope, which is 2. This is the slope that we have just now obtained, multiplied to x minus x1. So x1 is also -4. So we have +4. So we get y plus 4 equals to 2 times x plus 4, or we have 2x plus 8. So rearranging the terms, we get 2x minus y minus plus 4 equals to 0. So this is going to be the equation of the straight line, which is the perpendicular bisector of the line formed by joining the points A and B. Okay, let's move on to the next problem. Determine the equation of a line inclined at an angle of tangent inverse of 1/3 with the positive direction of x-axis and having an x-intercept equals to 4. The part 2, the y-intercept equals to -3/2. So these are two separate problems. We'll deal with number 1 first. Let us begin. So let's try to understand the problem graphically first. So here we are given the line is inclined at an angle of tangent inverse of half with the positive direction of x-axis. That means theta here is given by the inverse tangent of half, which means if we take the tangent on both sides, then tangent theta is going to be equals to 1/2. Now by definition, tangent of the angle made by the line with the positive direction of x-axis is nothing but the slope of that particular line. So our slope comes out to be 1/2, and this is a positive value. Since it's a positive value, this only implies that theta is an acute angle. Right. So we have a slope of half. Now this is true for both the two lines. One having an x-intercept of 4 and the other having an y-intercept of -3/2. Now since both of the two lines are going to have the same slope, it automatically tells us that the two lines are parallel to each other. Fine, so we'll go with that fact. Now first let's start with number 1. So here we're given that the x-intercept equals to 4. X-intercept equals to 4 means the line is going to cut the x-axis at the point A, which is going to be at a distance of 4 units from the origin. So this is going to be the x-intercept of that particular line, and since we know the x-intercept, so we can quickly obtain the coordinates of point A. So that's going to be 4, that's the x-coordinate, but the y-coordinate is going to be simply 0. And we're going to sketch a line which passes through this particular point A, and also the angle that it makes with the x-axis is going to be an acute angle. So here we have the line passing through point A. So it's making an angle theta with the positive direction of x-axis. So theta here is nothing but the inverse tangent of 1/2. Now using that information, we have already obtained the slope of the line. Now the line also passes through the point A, 4, 0. So we can use the point slope form to obtain the equation of that particular line. Okay, so let's do that. So here, let's write the information that we have. The line passes through the point A having the coordinates 4, 0 with slope equals to 1/2. Therefore, we can say that by using the point slope form, we have y minus y1. So here y1 is going to correspond to 0 equals to the slope half, which is half, multiplied to x minus x1. So x1 here is 4. This will be equals to, so 2y will be equals to x minus 4. So that's the equation of the line. And if we arrange the terms, so we have x minus 2y minus 4 equals to 0. So this is going to be the required equation of the line, which has an x-intercept of 4 units. Now let's go to the next part. So our line is going to intersect the y-axis in the negative direction at point B. So B has the coordinates 0, -3/2, meaning the distance of OB, that's going to be equals to -3/2. Now, our goal will be to determine the equation of this particular line which passes through this point. So this is the line, this is going to pass through point B, and this is also going to make the same angle theta with the x-axis, the positive direction of x-axis given by tangent inverse of 1/2. Now, we have the slope m, which we have already obtained, was half. The line passes through the point B, 0, -3/2. So the equation of the line is going to be given by y minus y1. So y1 is -3/2 equals to the slope half times x minus x1. So x1 is 0. So we have y plus 3/2 equals to x/2. Let's multiply throughout with 2. So we have 2y plus 3 equals to x. Rearranging the terms, we get x minus 2y minus 3 equals to 0. So this is going to be the equation of the line, which has a y-intercept of -3/2, and it makes an angle of theta with the positive direction of x-axis, where theta is simply defined by the inverse tangent of 1/2. Okay, let's do one more final problem. A perpendicular line is drawn from the origin to another line such that it meets the line at the point -2, 9. Determine the equation of the line. Okay, so let's try to understand it graphically first. So here we have the coordinate axis. First, let us try to plot this particular point, -2, 9. So let's say since it's a -2, 9, it's going to lie in the second quadrant where the x coordinate is negative and the y coordinate is positive. We'll suppose that this is the point A, which corresponds to the coordinates -2, 9. Now, what we'll do? We will join point A, O, and point A. Now, this line OA is perpendicular to another line. So we have the line denoted by L, and we have to find out the equation of this particular line. So this line is perpendicular to OA. OA meets the line L at the point A with coordinates -2, 9. Okay. Now, in order to find out the equation of line L, we need two information. One is the slope of the line, and the other is the will be any other one point that lies on that line. Now here we already have point A. Point A is going to lie on the line L. So that information is given. What we'll have to do is find out the slope of that particular line. So here we can find out the slope of line segment OA first. We're going to denote it by the letter M1. Now, to find out the slope of OA, what we need is the coordinates of point A and coordinates of O. O is the origin, so its coordinates are going to be 0, 0. So let's find out the slope of line OA. So what we do, we will take the difference of the y coordinate in the numerator and divide it by the difference of the x coordinate in the denominator. We have 9 minus 0 divided by -2 minus 0, which gives us the slope is -9/2. So let the slope of our line L, we're going to consider it to be M2. So this is the slope of the line L. Now we know for a fact that for two perpendicular lines, the product of the slope always equals -1, which means that M1, we already have the value is -9/2. This will be multiplied to M2 equals to -1. So here M2 corresponds to the value 2/9. So we have the slope of the line. We also have the particular point A, which lies on the line L. Now we are ready to find out the equation of the line. So our equation of the line will be y minus y1 equals to the slope times x minus x1. So here y1 x1 comma y1 corresponds to the point A with the coordinates negative 2 comma 9, which implies that the value of x1 will be negative 2. Value of y1, that's going to be positive 9. So we have y minus y1, so that's 9, equals to this loop 2 over 9 multiplied to x minus x1. So x1 is negative 2, so we have x plus 2. So let's further simplify this. We are going to multiply throughout with 9. We get 9y minus 81 equals to 2x plus 4. So we have 2x minus 9y plus 81 plus 4, that's going to be 85. So that's equals to 0. So this is going to be the required equation of the line L. The line L is perpendicular to the line OA, and it meets OA at the point negative 2 comma 9.